See, the most important topic today for either a risk manager or an investment analyst is how do I analyze the data? I have large volumes of data. Let's say we talk about the the returns related data on a monthly basis, daily basis, the stock market returns, a particular security returns, the profits of a company. There is so much of data that is floating around. The moment I see a typical data with me, what kind of analysis I do or I should do, that is something that is very much essential for any kind of an analyst position. That is where the importance of these topics, where statistical methods, probability, then the distributions in probability, as well as something to do with sampling and hypothesis testing. These are some of the spaces which are required for any kind of a job that we are typically performing. So with that in mind, if I look at this world of statistical methods, it all starts with understanding the various branches in statistics. If I have to first look at a data, what is the intention of looking at the data? I may have to do some calculations on that. And based on that calculation, I may have to make some conclusion. Right? If I can't derive any conclusion, then it is of no use. Just making a calculation may not be of much use. So, whenever we talk about the world of statistics, we talk about these two major aspects. How do I make the calculations? And based on the calculations, how do I interpret? Now, let's say someone has given me the returns data for the last 1 year, right? Daily returns or monthly returns of a particular company or a particular stock for last 1 year is existing, and now I have to find out what is the average return, or if I find out what is the average return, what do I mean by that? Or if I find out what is the standard deviation in the data, what do I mean by that? Right? Or how do I use it for my knowledge purpose, or how do I use it for my decision purpose? So from that standpoint, what we typically see is, in the world of statistics, we see that the whole breakup is into two aspects, the descriptive as well as inferential kind of statistics. The focus wise, descriptive means it helps us in doing the calculations, whereas inferential is the world where we make some kind of conclusions after looking at the calculations. And coming to our usage also here, the first chapter, the current chapter is more focused about descriptives, where we talk about different calculations that to be done. And from the next, there are a couple of chapters where we are talking of sampling, hypothesis testing, the probability distribution. These are all the chapters that will help us in making some inferences about the calculations which we are making. Of course, in the later stages, you also talk about regressions, time series. There is a lot more in the statistical angle, which as a part of the current, we are typically not looking at. Right now, we would be focusing more on the statistical calculations and primarily doing some kind of basic inferences after the calculation. Now, the next important concept which we need to be comfortable here is the differentiation between a population and a sample. The whole data, whatever we are considering, we call it as a population. But most of the times, the complete data is not available. Right? If I am talking about the monthly returns of a stock, right? What do I define as month? Is it from first to first or second to second? What is the definition of month? Everything is a month only. Or probably 9:30 a.m. on first day to 9:30 a.m. on the first day next. Even that is the definition of month. So typically what happens is, getting across the entire population is always a difficulty. So whenever I am taking some kind of subset of that population for my analysis purpose and for my decision purpose, decision I will never give on a sample. Decision is always given on the complete population, but using a sample itself. Most of the time, the election results, predictions, and all, they never come to all of us to say whom we have, to ask for whom we have voted for. But without our knowledge itself, they come out and say this party is going to win in this particular constituency. Because they have typically taken a sample of data, and based on that, they are trying to make some kind of conclusions at the whole population level. So even as a financial experts, we would also need to do a similar kind of analysis. That's where the understanding of statistics forms a very basic aspect of our knowledge base here. Now, whenever we talk about data, it could be returns, it could be profits of the company for the last few quarters, any data. The data, we always look at it in 4 different dimensions. Some cases, what we can have is, let's say, a gender, male, female, or the names of the funds, fund 1, fund 2, fund 3, fund 4. These are the data. Let's say one column of data I have, which is the names of funds, or one column of data I have, which is gender. In this data, this is typically not a number based data, it's a textual kind of a data, right? That textual data, we can create categories out of it. Fund 1 is a different category, fund 2 is a different category, or male is a different category, female is a different category. So based on the value in that column, we can create a different category. But so category means probably in a random order, I may say male, I will make it as 1. Let's say female, I am making it as 2. Some number I am giving both to male and female. But here, okay, 1 and 2 are just for categorization purpose. But there is no mathematical logic behind this 1 and 2. What do I mean there? 2 is, mathematically 2 is greater than 1. But I cannot say female is greater than male. No meaning to that. Or mathematically 2 is 1 plus 1. So I cannot say male plus 1 equal to female. No mathematical relationship, no arithmetic relationship can be built up into it. No logical relationship can be built up. Right? Which means, in a simple essence, the 1 and 2 are given just in an arbitrary manner. No ranking, they don't mean anything. Just a simple assignment or simple quantification we have done to the data. Such kind of scale, such kind of data, we call it as a nominal kind of a data. Then, if a particular data is having an order, the categories itself, but if it is having some kind of an order in it, for example, high, medium, low. Male and female, probably whatever is the sequence you give, there is no importance to it. You can give male as 1, female as 2, or female as 1, male as 2. No relationship can be built. No mathematical relationship can be built there. But in some cases, like your preference level, high, medium, low. Right? If you are giving 1, 2, 3 for low, medium, high, probably you are building some kind of a relationship, at least saying, okay, 2 is greater than 1, which means probably medium is better than low. Some kind of a ranking can be given, right? But the difference in the ranking may not be clear. By how much extent medium is more than low? That difference can't be known, right? But we can definitely say greater or lesser kind of stuff, but I cannot say by how much kind of thing. If that is the data I am working with, that data we call as the ordinal data, which is better than nominal, because we can at least talk about the relative ranking of that data, but I cannot say by how much. So such kind of data we categorize them as ordinal. Typically the grades, A, B, C, D grades. I can definitely say A grade guy is better than a B grade guy. I mean, from whatever the assessment is, A grade is better than a B grade. But by how much? Right? But by how much, if I can't say, then it is going as a ordinal scale kind of a data. Then getting into the third one, the interval based scale, wherein I can talk about the difference at least, which is more like, let's say we talk about the temperature, 10 degrees versus 20 degrees versus 30 degrees, right? Here people can very well say 20 degrees means 10 degrees more than the 10. 30 means 10 degrees more than 20. But they cannot say 20 degrees means twice that of 10 degrees. Right? 20 degrees temperature, 20 degrees C is not twice of 10 degrees C. You accept that? Simply you convert it. If I convert this into a Fahrenheit scale from a centigrade, right? Probably by doing into 9 by 5 plus 32. That's the conversion factor which we use. Right? So this is 10 degrees C is coming out to 50 degrees F. Whereas 20 degrees C is coming out to 68 degrees F. It is not double. Right? Whereas the same way if you go to the next, it is working out to 86 degrees F. What is it telling us? In one unit, probably it is showing a doubling behavior, whereas in the other unit it is not showing. But the difference is consistent here. Here the difference is 10 degrees C. Here also it is 10. Even if I translate it into another scale, the difference is still 18 only. The difference is consistent, but not the ratio. Ratio means if I multiply with something, the consistency is not existing. Such kind of data where the consistency does not come with the multiplication, but it comes with the difference, is what we call as an interval scale data. Especially wherever you are doing a band, right? And probably especially if your data is having a form y equal to some mx plus c. This kind of a form of a data, even your Fahrenheit is nothing but 9 by 5 times the centigrade plus 32, which is almost of the form of y equal to mx plus c. Whenever you have a data of that form where plus c is there, plus a constant is there in your formula, it cannot go with the doubling or tripling kind of relations. It can only go with the difference getting addressed correctly. So there, even in finance, as we move along, we'll see there is one extraordinary formula which is typically used in the world of finance, which is typically called as your capital asset pricing model formula, which we'll see slightly later. But that itself follows an interval scale for us, because the formula which it uses again is more of the form of y equal to mx plus c kind of a form. So whenever you see a data which does not have a true 0 degree C, it doesn't mean that there is no temperature, right? But if I say 0 centimeters height, probably it is clearly saying, okay, this person does not have any height, or this entity does not have any height.